Hello, this is Vivek Babele, Assistant Professor, Oriental Institute of Science and Technology, Department of Automobile Engineering. Today we are going to discuss principle of machining, advanced machining processes, in which first we will discuss about types of advanced machining processes. So number one is chemical machining, then electrochemical machining, electrical discharge machining, wire EDM, that is wire EDM, laser beam machining, electron beam machining, plasma arc cutting, ultrasonic machining, water jet machining, and abrasive jet machining. The need for advanced machining processes is due to cause in traditional machining processes, material removal by mechanical means such as chip forming, abrasion, or microchipping. Advanced machining processes are utilize chemical, electrical, and high energy beams. The following cannot be done by traditional processes: workpiece strength and hardness very high, that is greater than 400 HB. Workpiece material too brittle, glass, ceramics, heat treated alloys. Workpiece too slender and flexible, hard to clamp. Part shape complex, long and small hole, special surface and dimensional tolerances requirements. Typical parts that can be made by unconventional machining is the skin panel for missiles and aircraft, turbine blades, nozzles, sheet, small diameter deep holes, dies, thick metallic and non-metallic parts. Chemical machining is the first, in which chemicals are used to dissolve the material. Then masks are used to control attack. Most common use is circuit boards and plates for printing. Cutting speed is 0.0025 to 0.1 millimeter per minute, which is very slow. This is the diagram for chemical machining. Second is electrochemical machining, in which combines chemical attack and electrical attack. High material removal rate. Masking is used to control attack. Conforming electrodes are to control shape, commonly used for aircraft parts such as aerofoil shapes, normally followed by abrasive finishing or laser peening to remove partially adhering particles. Works with a wide variety of metals. And this is the diagram for electrochemical machining. You can see that. Next is electrical discharge machining, in which successive electric arcs melt tiny droplets from surface of workpiece. Frozen droplets must be flushed away. Electrodes are made from graphite, copper, or copper tungsten alloy. Material removed from electrode by arc, recast layer of approximately 0.001 inch in depth left on surface. Secondary process such as chemical machining used to remove recast layer. Next is wire EDM, that is wire electrical discharge machining, in which uses fine brass wire. Wire is used once, easily computer controlled. Cutting path must contain straight lines, slow cutting speed. Wire breakage is a problem. Shallower recast layer than conventional EDM. Next is laser beam machining, in which direct laser beam against surface of workpiece as in laser beam welding. Success pulses from laser gun vaporize tiny bits of workpiece. Location of laser beam controlled by computer. Workpiece need not be conductive. Cuts are tapered and got a trap overshoot from laser beam. Laser beam machining, in which it produces large remelt zone, can produce holes as small as 0.002 inch diameter, can produce deep holes used to produce cooling holes in blades, vanes for jet engines. Next is electron beam machining, in which workpiece placed in vacuum chamber, high voltage electron beam directed towards workpiece. Energy of electron beam melts, vaporizes selected region of workpiece. Electron beam moved by deflection coils. Similar process to electron beam welding. This is electron beam machining. Next is plasma arc cutting. Plasma is a stream of ionized gas. Typical temperatures are very high in this process. Same process as plasma welding without filler material. Torch movement controlled by computer. Power requirements depends on material being cut plus depth of cut. Recast layer is deeper than with other processes, and other process is in unconventional machining is ultrasonic machining, in which abrasive slurry flows over top of workpiece, that is loose particles. Cutting tool vibrated by ultrasonic energy. Abrasive particles between tool and workpiece do the machining. Works well with hard brittle workpieces. Next is water jet machining, in which narrow jet of water directed at high pressure and velocity against surface of workpiece. A jet of water erodes surface of workpiece, thereby cutting workpiece. Computer control to achieve shape. This is diagram for water jet machining. Next, abrasive jet machining, dry. Similar to sandblasting, except that a very narrow jet of air abrasive particles achieves localized cutting. Computer used to position jet. This is the diagram for abrasive jet machining. Nano fabrication methods typically used in the semiconductor industry combines the lithography technique of chemical machining with an atomic force microscope, may incorporate plasma cutting reduced to nanoscale. Now we can discuss the economics of advanced machining processes. High cost of equipment, which typically includes computer control, may use hard tooling, soft tooling, or both. Low production rates, can be used with difficult to machine materials. Highly repeatable, typically requires highly skilled operators. There are some companies in which advanced machining is used.